Alright guys, this is Dr. Daniels, level 4. We're going to talk about ABGs. So first of all, we needed a normal, right? Before we can figure out abnormal. So normal pH is 7.35 to 7.45. The acidic side is anything less than 7.35. And alkaline side is greater than 7.45. Normal values for CO2 are 35 to 45. So what is CO2? CO2 is acidic. It's typically associated and best supports the respiratory system or respiratory status. So when we talk about acidity, things that really affect it are things like hyperventilation. So if we're hyperventilating, we're breathing a lot, right? Our respiratory rate goes up. So if our respiratory rate goes up, we're able to blow off a lot of CO2. If we're blowing off a lot of CO2, the CO2 in our body goes down. This becomes alkalotic then, right? Because we have decreased CO2. Hypoventilation, that means our respiratory rate is down. That means we're not breathing as much. If we're not breathing as much, we're not blowing off as much CO2, so our CO2 is going to go up. And because CO2 is acidotic, increased CO2 relates to an acidotic state. Bicarb, normal values for bicarb are 22 to 26. Bicarb is alkalotic and is more related to a metabolic state. So things that affect your bicarb is things, it comes out of one of two ends, basically. Oh, sorry, bicarb is produced by the kidneys, the pancreas, the liver. So it either comes out the bottom end, so things like diarrhea, and you lose bicarb. So again, because bicarb is alkalotic, if you lose that alkalotic state through diarrhea, you're going to have an acidosis. And then if it's not coming out the bottom end, it's coming out the top end. Vomiting, MG tube. So with that, you lose, with vomiting, MG tubes, you lose acid. You're actually retaining bicarb, and that becomes more alkalotic. So let's look at this and play it out. What I always like to do is at the top of your paper, I like to write this. Everything acid, base. So everything on the left side is acidic, and everything on the right side is alkalotic or base. So if it's less than 7.35 or greater than 7.45, now the CO2 you have to kind of switch around, right? Because if it's greater than 45 or less than 35, right? Because CO2 is related to acid, so the more CO2 you have, the more acidic state you're going to be in. And then bicarb is 22, 26. So if it's less than 22 or greater than 26, less than 22, you're going to be in an acidic state, and base, greater than 26, you're in an alkalotic state. It's a base. So looking at our practice, the pH is 7.31. So, I'm sorry about that. Let's go back. So pH is less than 7.31. So at this point, we're acidotic. Right? We're looking at this right here. Acidotic state. The PCO2 is 52. So again, it's acidotic. The bicarb is not affected. It's kind of in the middle. Okay? So if we know that CO2 is related to respiratory and the pH is low, we've got a respiratory acidosis. Now let's look at the next one. Again, 7.53. So again, we're looking at this acidotic state. The CO2 is normal, so we know it's not a respiratory issue, or we don't think it is. And the bicarb is 32. So we're looking at alkalosis. Now, we're going to talk about why. Oh, I think I pointed at the wrong side, the acid side for the pH. Sorry about that, guys. So when you go back, let's go back for a second. pH, we're looking at the base. So it's greater than 7 point, so where it's alkalotic. And we said CO2 is normal and the bicarb is high. So we're looking at a metabolic alkalosis, because with this is HCO3 and CO2. And we know CO2 is respiratory, and we know bicarb is metabolic. All right, let's do a couple more practices. So when we talk about, we're going to talk about partial compensation and full compensation. We're looking at, we're going to ask ourselves those questions. So is the CO2 out of range, is the bicarb out of range, and the pH is out of range? So when we have partial compensation, everything is out of range. So then we're going to ask ourselves, again, we draw ourselves that little acid and base, 7.35, 7.45. $45, $35, $22, $26. And we know this is respiratory and this is metabolic. So we look at it and we say, is the pH, is it acidic or alkalotic? Is the PO2 up or down, and how could that affect the pH? And is the HCO3 up or down, and how does that affect the pH? So let's look at a partial compensation. Again, I'm going to write my little table because I'm a visual person and I like to see it. So 735, 745, 45, 35, 22, 26, respiratory, metabolic. All right, so is the pH on your acidic side or your base? So looking at this, it's 7.31, so I'm looking at more acidic, right? So it's acidic. Your CO2 is 52. So is it acidic or base? Well, it's 52, so it's acidic on the acidic side. Your bicarb is 28. Is that acidic or alkalotic? That's high, and that contributes to alkalosis, not acidosis. So when we look at this, we know we have, everything's out of whack. So you're like, how do I figure this out? Well, we start with the pH. The pH is acidic. Then we want to figure out, is the CO2 or the bicarb contributing to that acidosis? Well, because the CO2 is high, that's on the acidic side. So we know that it must be respiratory, because respiratory is with CO2, right? Acidosis. The bicarb is high because it's trying to compensate, right? It's trying to balance these two out. So the bicarb is high, but it's not going to be metabolic because bicarb produces an alkalotic state. If we had high bicarb and it was based on metabolic, we would expect the pH to be, an alkalotic state, and it's not. It's acidic. Let's keep going. So this is partially compensated respiratory acidosis. When we have full compensation, the pH is normal, but the CO2 and the bicarb is out of range. And this because the body's done its job. the pH becomes normal because the bicarb and HCO3 are balancing each other out. They're going to kind of opposite ends. So again, we're going to ask, is the pH normal? Is the pH more acidic or base? And which one is contributing to it, the CO2 or the bicarb? So again, I like to write my little acid, base, 7.35, 7.45, 45, 35, 22, 26. And this is respiratory, and this is metabolic. So, is the pH normal? So 7.43, yep, it's normal. Now what we look at, though, is it more acidic or is it more alkalotic? So we could say, what, 7.4 is our little middle range right here. So anything above 7.4 is more alkalotic, and anything less than 7.4 is going to be more acidic. So we would say this pH is normal, but it's more on the alkalotic side, right? So it's normal, but it's more a base. Then we're going to look at the CO2. The CO2 is 54. So is the CO2 high or low? Well, it's 54. So we're looking at an acidotic, right? So if we're looking at a alkalotic base, does the CO2 contribute, a high CO2 contribute to an alkalotic base? No, it doesn't. A high CO2 would contribute to an acidotic state. So we know that it's not the CO2. Now let's look at the base. The base is 35. Well, right here at my 26, does a high HCO3 bicarb contribute to an alkalotic state? Yes, it does. So if we know that it's a base is metabolic, or I'm sorry, bicarb is metabolic, we're talking about a fully compensated, because the pH is normal, fully compensated metabolic alkalosis. That's supposed to be alkalosis. Okay? Just so no one gets confused. Fully compensated metabolic alkalosis. So again, I hope everyone will get more practice in the roundabouts, but I would always draw that little table and see where the pH is and what contributes to the pH. If the pH is alkalotic, you either need a high CO2 or a high base. If it's acidotic, you need a bicarb or CO2 that's going to match that. I would say just keep doing practices if you can. So respiratory alkalosis, again, the alkalosis happens because we end up blowing off a lot of CO2, right? So if they're hyperventilating because they're anxious, because of fear, maybe we're ventilating them and they're ventilating too much, they tend to blow off a lot of CO2. So that drives the CO2 in the body down and we lose it. So we blow off the acid. You can get numbness and tingling with this, lightheadedness. Acidosis, again, you get the respiratory depression. These are the people who, like anesthesia, overdose, high ICP, so they're not breathing effectively. So they're not blowing off the CO2, so they're retaining it, so they're retaining acid. If they're retaining acid, their pH is going to plummet, right? They also might feel dizzy. So, I'm sorry, back to this real quick. So they're going to feel dizzy. They're going to be a little disoriented probably. But, so these patients, if they're not breathing correctly, the respiratory rate is too low, they're developing, you know, like this hypoventilation, hypoxia. And if it's because of things like overdose or high ICP because they have a head trauma, the best way to treat it is to vent them, right? Is to put an ET tube in and vent them. We want to control, we want to increase that respiratory rate so they can start blowing off the CO2. Because if they don't blow off the CO2, they're going to retain that acid. Metabolic alkalosis. Again, this is when we talk about like diarrhea. So, vomiting. They are going to get rid or have a high bicarb, right? Because they're retaining it. So, alkalosis, high bicarb. They lose acid, so the bicarb goes up. And metabolic acidosis, again, typically caused by, it's nausea, vomiting, diarrhea. I'm sorry, not nausea, vomiting, diarrhea. I'm going to go back one. Alkalosis is the vomiting. Vomiting. Anything that comes up the top end. Vomiting. They could do NG tubes. I apologize, guys, if I confused you just now, but alkalosis is, I was looking at the wrong slide. Alkalosis is anything that comes out the top. Vomiting, NG tube. They're losing the acid, so the bicarb goes up. Acidosis, think of, you know, the bottom end, acidosis. These are the diarrhea, right? They have too much acid, so they're in too little bicarb. Okay. So the important thing is to understand, you know, write down your little paper, see if your pH is, you know, as always, let me see if I can do a different color. Always do, you know, acid, base, so if it's greater than, less than, 45, 35, greater, less, 22, 26, less, greater. And everything on this side is base, and everything on this is acidic. And knowing that CO2 is respiratory, and bicarb is metabolic. And then you look at your pH, and are your CO2 and your bicarb, do they contribute to an alkalotic state or to an acid state? And understanding what then causes this, like respiratory, hypo versus hyperventilation, metabolic, which end does it come out of? That way we know how to treat. So if we know we're having respiratory acidosis because we're retaining CO2, we know that we need to help a patient blow off the CO2. If we know that we're getting an acidosis because the patient's having lots of diarrhea, then we need to know we need to help that patient by correcting the diarrhea or giving fluids. So being able to look at this, figure out where it comes from and what causes it, that's where we come into play, because we want to help correct the problem once we see it. And again, when we get to roundabout, we'll talk about this more and go over it more, but a quick little brief overview for you guys. I'm sorry if I confused you with the metabolic stuff, but but just review the alkalosis, vomiting, and G, acidosis, diarrhea. All right. Have a good day, guys. Bye.